Hello students, through these slides we will be dealing with universal soil loss equation. Okay, so universal soil loss equation, it is presented by Wishmer in 1959, which can be adapted to a wide range of conditions. Okay, this universal soil loss equation we can say USLE, which is given by A equal to RKLSCP, the 6 factors. Okay, where A is the average soil loss and given in tons per hectare per year. We can say average annual soil loss also. Over the years, how much amount of average soil loss is there, we are quantifying with USLE. Okay, where R is the rainfall erosivity index, K is soil erodibility factor, L is the length of slope, S is the steepness of slope factor, then C is the cropping management factor, then P is conservation practice factor. Okay, let us see one by one. So the first one is soil loss A, which is soil loss per unit area per unit time. Okay, so it is given in metric tons per hectare per year, average annual soil loss. Okay, so the first factor is rainfall factor, which refers to the rainfall erosivity index, that is ability of the rainfall to erode the soil particles from unprotected field. Okay, it depends on two rainfall characteristics. One is kinetic energy, then another one is 30-minute maximum intensity of rainfall. Okay, it is a numerical value. This R factor is a numerical value. Okay, so soil erodibility factor, when I say it is a particular soil becomes susceptible to get eroded either by wind or water. Okay, it is the susceptibility of the soil. Okay, so here the mechanical composition of soil such as sand, silt and clay will be a major factor on which the soil erodibility depends, and it is given by E is equal to percentage sand plus percentage silt divided by percentage clay. Okay, so soil erodibility, it is expressed as tons of soil per hectare per unit rainfall erosivity index from a field of 9% slope and 22 meters as field length. So this 9% slope and 22 meters field length, it is a unit plot we will say. From this plot, how much amount of soil is eroded per hectare per unit rainfall erosivity index. Okay, that is the K factor. Then next is length and steepness of slope factor. So slope length for eroding portion is from this point to this point. Okay, this is called slope length for eroding portion. So this is the portion of soil which is eroded in this hilly areas and it is deposited here. Some amount of soil will be mixed with the water and it is flowing as sediment. Okay, so this length is called as slope length. Okay, then steepness, when I say, see this line is not steep, little steeper, even steeper. This is more steep. Okay, very steep line. Okay, likewise the slope here we can say it is like a little steeper. Here it is even steeper. Okay, so slope length has a direct relationship with soil loss. Then steepness of soil increases, soil erosion also increases. Okay, so when I say length and steepness of slope together, it is called as topographic factor because it depends on, it is giving the topography of the area, so it is called as topographic factor. Okay, next one is crop management factor. Crop management factor, it is defined as expected ratio of soil loss from a cropped land under a specific crop to a fallow land. Okay, to a fallow land. Then conservation practice factor P, it is the ratio of soil loss from given conservation practice. It may be a contouring, terracing and strip cropping to the soil loss obtained from up and down the slope. Okay, up and down the slope. This is called conservation practice factor P. So how this USLE is applied? It is used to find the soil loss. It helps in selecting the agriculture practice to be adopted to reduce the erosion. Then it provides recommendations on crop management practices to be used, which is good. We can find with this USLE. So limitation, it is an empirical formula, so there is no mathematical relationship in this formula. Then it predicts average annual soil loss, so we cannot predict over the months or like that. We cannot predict, only we are predicting average annual soil loss. Then it does not compute gully erosion, because this universal soil loss equation is for only sheet erosion and drill erosion. Okay, then it does not compute sediment deposition also. These are all some of the limitations of USLE. Thank you. If you have any doubts, you can write to me. Okay.